Okay, so the next type of inequality we want to talk about how to solve is absolute value inequalities. So these are the exact same process to solve an absolute value equation as we've seen so far. You're still going to set up two inequalities, one with a positive result, one with a negative result, same as you do with the equations. The difference is you need to make sure when you set up your negative result, the second equation, in addition to rewriting the number as a negative number, you must also switch the inequality sign before you go ahead and solve. So for example, if I want to solve this inequality right here, absolute value of 3h minus 3 is less than 12. We'll set up first with the positive results. Everything stays the same. Separate second, where now we use the negative result and we flip the inequality sign. We flip that and change the number. So when we add 3 to both sides, we get 3h is less than 15, divided by 3, h is less than 5. Here we have to add 3. We get 3h is greater than negative 9, divided by 3, h is greater than negative 3. Now we're not quite done, because with these absolute value inequalities, half the problems we can combine this into one compound inequality solution. Whenever the absolute value is less than a number, like this can combine into a compound inequality. Another way to check yourself, so we're saying h is less than 5, so if we pick a number that's just less than 5, like 4 for example, is 4 greater than negative 3? Yes it is, so I can really rewrite this expression, h less than 5 and h greater than negative 3, is negative 3 less than h, less than 5. Again, you'll find whenever using the absolute value is less than the number, your two solutions can combine, where it's the small number, less than, variable, less than the next number. If one of these is an equal to sign, that's fine. And again, one way to check yourself, you just pick a number that's very close to this, but still satisfies it and see if it works. Like for example, negative 2 is greater than negative 3, so we use that. Negative 2 less than 5, yep, still works. So we have the absolute value of 4p plus 2 greater than or equal to 10. Well, we set up two inequalities. 4p plus 2 is greater than or equal to 10. 4p plus 2 is less than or equal to negative 10. Again, negative result, flip the inequality. So we subtract 2 from both sides. 4p is less than or equal to 8, divided by 4. p is greater than or equal to 2. Here we subtract 2 from both sides. 4p is less than or equal to negative 12. We divide by 4. p is less than or equal to negative 3. You'll find when we're using the absolute value is greater than a number, we cannot combine the inequalities. Again, one way to check, you pick a number that's close to 2. So for example, 3 is greater than 2. Is 3 less than negative 3? No, it is not. So we cannot combine this into a compound. We must write them as two separate solutions. P is greater than or equal to 2. P is less than or equal to negative 3. So why don't you go ahead and solve this absolute value inequality on your own. Set up your two inequalities, go ahead and solve, and then determine if you can combine or you can't combine. Alright, so when you set up your two inequalities, you'll have negative 5x plus 2 is greater than 14, and negative 5x plus 2 is less than negative 14. Solve those, you'll get x is less than negative 2.4. Don't forget to flip this because we have a negative. You get x is greater than 3.2. Again, don't forget to flip because you're dividing by a negative. And again, since we're greater than, and our test values, like for example, negative 3 is less than negative 2.4, certainly not bigger than 3.2, that's how we know they're two separate answers. We cannot combine it into a compound. One more to try on your own. I want you to solve this one by combining them, if you can. But just make sure you rewrite your two inequalities first, to then solve each separate, to then see if they can combine at the end. Okay, so for this one we have our two inequalities. Negative 8y plus 6 is less than or equal to 19. Negative 8y plus 6 is greater than or equal to negative 19. When you solve, you'll get y to be greater than or equal to negative 1.625, and y to be less than or equal to 3.125. This can combine into a compound inequality. Again, we're dealing with less than, that's how we know we can do it. Now, before we finish this video, we got to talk about two special situations. First, absolute value of 8x plus 5 is less than or equal to negative 9. Now, negatives with absolute value equations are very straightforward. If your absolute value ever equal to a negative number, it was automatically no solution to even have to think about it. Absolute value inequalities, you need to think a little bit first. because while it is true in this particular case the answer is no solution, it may not always be the case. The reason why this is no solution is because the absolute value can only give you positive results. So positive is never less than negative, so it's impossible for this to be anything besides no solution. However, in this case, if the absolute value of negative 6y plus 2 is greater than negative 3, since the absolute value has to always be positive, positive is always greater than negative, this one is infinite solutions. So with absolute value inequalities, unlike the equations, you have two possible answers when it's negatives involved. Either no solution, because we're less than a negative number, or infinite solutions, because we're greater than a negative number. You have to keep that in mind. Don't assume it's no solution just because you see a negative number. Alright, just one more section to go. We're going to talk about how to graph linear inequalities. So I will see you next time.